Okay, so in this video we're going to cover the adjustments that are here, and also note that they are also found over here. We have an overall amount of whatever result there is there, which is kind of like a blend between that. And then we have our auto level, invert, bias gain, and clamp, which we're going to be looking at in here. So starting with the mountain shape as a basis for this, I'm going to jump into the threshold, and the threshold is essentially a black or white kind of value. It's either on or off. It's pretty much how it works. But it does have some interesting features. I'm just going to quickly take this, right click, and I'm going to pin it so that we see this as the result. And I've already pinned the mountain for color just by right clicking and saying pin for color, in order to be able to see this mountain, which is what we're affecting, with this black and white reference. So if we look at this, right now it's essentially just height information that's changing. If we go between different values, you can see that it just goes ahead and cuts itself at different height values. And it's pretty absolute. However, if we adjust something like invert, which is pretty straightforward, we get the reversed version of this. And so, of course, what this would look like is all the white stuff goes up and all the black stuff would go down. But that's what it's basing it on. It's basing on that one slice of it there. If we were to switch, however, to something like adaptive, when it adapts, it goes and checks out its neighbors, so things that are nearby it, until eventually it reaches a cutoff. A lot of what scale is just going up and down, choosing that range. Eventually, not going to see much more. So, if I were to pop out of this and switch instead to this, you can see how it represents there. Let's switch to clamp. Clamp allows you to clamp off max and min values. So in just a regular clamp value, we can lower that range, keep it up. There are other modes to the clamp, so we can do something like clip. If we go with clip, get it down a little bit more, there you go. And it essentially cuts off that thing, flattening that region, so flattening all the values above it to that max value. If we were to go with extend, as we come down, I'm going to reach that point, and you can see it takes anything at those values, and similar to threshold, it will bump them all the way up. The only thing is that anything underneath doesn't get flattened as well. So it's not completely absolute, it's partially absolute. And this can be useful for making mesas, which I will redo a video on that at a later point. If we go to bias gain, we have an intensity and a bias. As we adjust the intensity, you'll see that we're looking for that kind of range of intensity that we're working from, and it will push the whole thing completely up, or we have a max intensity kind of that, and it looks like it's sinking into it. So that can be fairly useful. So you could go and use that to cut off a lower range. If I were to go ahead and adjust my bias down, now playing with that along with the intensity, you see that you can create that balance between them, essentially lowering the entire thing. So it's sort of a game between these two, trying to find that point. So it just handles things in a different way. By the same token, if I went with this this here, I could also create a similar kind of effect with things like clip in both directions. So these are all sort of variations on the same kind of idea. When we go to auto level applies a variety of different things. You have the overall strength of the auto level, how it raises the entire thing. And if I just move, say, something like this, we look at equalize. And equalize will try and equalize all the values so everything ends up kind of flattening out to a certain degree. And then you have a value there, and then you have things like auto gamma, which in this particular case is not going to do anything. And then apply gamma, auto gamma, and now you'll see it. So you have to apply the gamma first, and that is pretty similar to what happens with the auto equalize. We're going to look at the gamma separately, so I'll just kind of leave that alone. Invert I put here just quickly because it's pretty straightforward what it does. You have the mountain, you invert it, it's kind of like pulling a sock inside out. It's not much to it other than that. Moving over, have a simple gradient, and I'll play with the gamma. Here, raising the gamma up, we'll bend that in one direction. Bringing it down, we'll bend it in the other. What it does is it leaves white at white and black at black, but all the mid values get shoved around, changing this. So it can affect slopes. Flip is pretty straightforward, just flips it over. Transform, on the other hand, will take that information and move it around. So I've affected scale, change the scale down, and use the X and Y to shift it over to this new position. If I were to play with something like the angle, you'll notice the angle works a little bit differently, and that it looks like it's getting sort of chopped off. But you have to think about the gradient as what it is right now. There's two factors going on here. One is the actual shape of this little wedge of cheese, and if we keep it like that, and then the other is that little box that we've got in there that represents the mask that we're taking and moving around and scaling the size of. So if I change this angle, I'm rotating it such that the back of that gradient and the front of the gradient are here, but they're also getting cut off by the edges of that mask. And so it creates this illusion of this weird kind of shape. One of the ways that we can fix this, turning on the mirror edge, which will fix some of these things, but it will take that and sort of mirror it back out the other direction. So that's the transform. For something like displace, displace goes ahead and applies either a standard noise, which you can, of course, scale the noise. We can adjust its complexity. There we go. Play with its seed, move its location around, and so on and so forth. We have uniform and non-uniform, changing not just the horizontal but the vertical values as well. So pushing it up versus sideways. We can switch to vertical. This is mostly vertical. And what you end up seeing is this edge gets pushed up. This edge is going beyond its limits, so it's mainly just pushing upwards. And again, we have the same kind of noise factor going on. Then if we switch to something like rugged, rugged gives us a different kind of noise pattern. Again, similar to the standard, same kind of features here, moving these things around. Just shifting the noise pattern. in X and Y directions. If we were to go to custom, custom allows you to plug in any kind of other item to displace with. So you can use alternative shapes to then change it. You have a strength, you have a uniformity, again same thing, and I'm not sure where this comes in at the moment because it doesn't really do anything in the custom situation, but it's there, maybe for a later use. The next in our list is the sine wave. If I just bring this back to its defaults, it does a singular sine wave. This is again based on this linear gradient. If we look at this, the way that the sine wave works is that it raises and lowers a value, so it creates this max and min kind of setup. As we increase the number of iterations of that, we increase the overall results of that sine wave. If I were to change the input here, let's say we'll switch to say a radial, give it a moment to build that, and we take a look and see that we get that sine wave pattern going in a circular fashion. I could also go ahead and go to the helix version of the gradient, which produces that. And when we change the sine pattern here, we get these different sort of petal ideas, which could be interesting. Let's switch this back to the linear gradient. I'll get a little bit closer here for this next part. So I'm going to go ahead and add a noise to this surface so that we can see what's going on. If I were to go with sharpen, of course what we would expect is all the small details become sharper, edges become more obvious, and we can see the detail in there. By the same token, we could go ahead and apply a denoise. Now the denoise, the higher you take it, the longer it will take to calculate. However, it won't always remove everything. The idea of the denoise is to remove small noise. And so sometimes just leaving it around a 1 to 5 range will be sort of the maximum of what you're going to get out of it. So don't expect it to do, amazing things. It's meant to go in and kind of soften the noise that's here. So we've got that noise pattern. All the small noise has been removed by the denoise, leaving the bigger noise around. So if there is no more small noise, I could keep on going and going and going. It's not going to do anything because it's looking for the small noise. On the other hand, we have tools like the heal node. And the heal node is going to do a slightly better job at dealing with some of those distortions. It's meant to heal information coming in from maps that may have a bit of pixelization, right? The range is not quite well developed. It may be like an 8-bit image or something like that, or other details, polygonal edges that weren't meant to be there because the resolution of the mesh from which the displacement was produced isn't that great, and so the heal will go in and adjust for those things. So heal does a really good job of removing that kind of content without really disturbing the actual sharpness of the edges. So it tries to maintain a lot of the original formation by sort of providing a small blur but then maintaining its shape. In contrast, something like the blur node can of course remove the noise pattern, but you see how it softens that edge. So where heal maintains that edge, blur softened the whole thing, but it hasn't maintained that edge. Now remember, this edge is still sharp because this is the actual edge of the overall geometry. There's nowhere for it to go, so there's nothing to that. But that right there was the tippy top, and that has to that ends up being softened. So blur will remove larger and larger scale detail the higher you go. There are different formats of blur which will provide different overall results. So this Gaussian here has maintained detail, the power has gone high, but if we play with a sigma, we'll see things get softer. If I went with something like a radial blur, we have a different sort of result. There's a little bit of artifacting that's happening here, but you can see that round and round pattern for the radial blur. A motion blur, of course, will create streaks across. And then just a regular smooth function right there, and we'll have a power for that as well. For this next one, I'm going to bring up the constant. We didn't look in the last video. Constant is just pure height, and it's often used to add value to certain areas, or to use as something to mask from something else, so that you can get the height off of it and alter the height very quickly and easily. It's just another way to do that. In this particular case, it's useful for showing off this next piece, which, as this is just a big sort of square, we have the zero borders. The way that zero borders is interpreted by default is just basically a large radial gradient, and it cuts off these things just to zero everything off, and it tries to create a smooth transition. If we were to switch to the square version, it doesn't look very square right now, but that's because it's set to auto. So we're seeing very linear kind of fall off straight there. And if we turn off the auto, then we get something that's a little bit more squared off. And we can change that fall off, which will cause the edges to lean, as it were. And of course, that margin just pulls that whole thing in. Now, even if we go with this original round version, which gives us this nice soft kind of range, it does lower, right? The top level there of our constant is there, and we bring it here, and you see it's lowered significantly. And that's to ensure that, you know, the edges go nice and smooth. After something like this, you can apply something like an auto level to bring those ranges back up, should you desire, or do it as an actual node where you can control the influence of it. Lastly, we have ourselves two gradients here, and we have our combine node. The combine node works very similarly to what Photoshop does with layer blends. So there's the straight up blend where all this direction is just this one. We have, you know, 50-50 between the two of them, or all the other one. If we were to go ahead and go to the add mode, it's going to add them together, and it's always going to be adding one to the other. So here it's adding the radial gradient, which is the B input, to the linear gradient. And it's clipping here because it's maxing out. It's going past the maximum volume or maximum height that can be allowed. These are simple math operations, and you can look them up. There's a Wikipedia article talking about the different layer blend modes, and not all of them apply. We don't have things like soft light and all that kind of business in here. These are the key ones that are there, and then of course there's other stuff like, you know, power, which is an exponent, square root, and I think the other one is difference. So we have these other ones in here, and they're just simple math. So a few easy examples This is the screen operation, so it's 1 minus a times 1 minus b, and you can see the end result. We got that there, which is different from the pure add, which would give me a 0.8. Multiplication often looks like it gets to a smaller value, and that's just the nature of multiplication. When you multiply against a value lower than 1, the values underneath it get lower. If you go and multiply against a value that's higher than 1, however, then you would get much larger values. But typically the stuff that we're dealing with in here is staying in that range of 0 to 1. So it's always going to look like it's losing values. And then of course we have subtract, which again differs from multiply in a few ways. There's the divide, and the one that is most frequently used is the max and sometimes the min. Just to quickly show you what that does, if we go with max, and let's turn that all the way up, what it does is if you look at the radial gradient, it's sitting right here, and this gradient, that value here is higher than the values in this gradient, and so therefore it keeps those. But the rest of them are all higher in this one, so it keeps those. If we were to switch to a min version, you notice that all the smaller values coming from this radial value, but some of the smaller values comes from this one, just in that area where it slices. So you can use this to carve out one shape from another, or to add another shape to the other. If you're familiar with the term Boolean in 3D, this is very similar to sort of a Boolean operation, a Boolean add and a Boolean subtract. So that's how that one can work. I do have a separate video on this channel which talks more in depth about using the combined node and masking things. So feel free to check that out if you want a little bit more information. So that covers the basics of these nodes. Just a quick comment here. I'm just going to delete this combine node, and if I grab the two of these and click right here, it will automatically generate a combine node for me. And if I were to grab multiple nodes and do that, just give it a second, it's going to create additional combine nodes where it combines with the combine, with the combine, with the combine, and so on and so forth. So you can always connect a larger number of them all together to do different kinds of operations. Also, in this method of combining these things, if you want to look for sort of happy accidents, you can just simply go ahead and down arrow after you've picked one of these and just sort of flick through the different versions and see what it gives you. Maybe it might give you something interesting. It's an opportunity to play around and sort of mess with what's there, just to see what you can get. So as always, I recommend heavily exploring these settings and seeing what you can get out of them. Try them in different ways just to get a better handle on how they would operate. The more you use them, the more intuitive your ability to use them in the way that you want will become, so that you'll be able to predict what kind of results you might get. If I add this with this and use this value, I have an idea of what it's going to do, and that only comes from experience. As always, hopefully this has been useful. We'll move on. I believe in the next video I've had requested just to jump quickly to the sculpting tool, and then we'll jump back into the filters and some of these other ones.